Welcome to the Graph Algorithm playlist. Hello. Now, in this playlist, we are going to need to know about the word trees and the word spanning tree. I think most of you might know something already about it, but I thought of making this video just to give you a short introduction to some stuff we need to know. So, I'll first start with introducing you to trees. So trees are just undirected graphs and they don't contain cycles. Now, that's simple. Here, if you see these examples, in this first case, the graph has cycles, it's not a tree. In these other two cases, the graph doesn't have, is not having a cycle, and these are not trees, these are not graphs, these are trees, and they have undirected edges. So these are just a subset of graphs, or these are just a special type of graphs. Now, if they are just they're not something new, they're just special cases. Why do we need a new name, or why are we studying these things separately, or why do we need a new kind of terminology? So trees are frequently used data structures. They are important enough to be studied separately. Now, for the sake of nothing, and just bear with me, just hang on with me. Let me introduce you with spanning a graph concept. So, what is spanning a graph? Now, what the word spanning mean? It basically means to span something. That's simple. Now, to span the whole graph, you need to visit all the vertices because spanning is that thing that you have to span a certain thing. You need to cover all the area it has, or all the spread it has. Now, a spanning tree. Now, if your task is to just span the graph, you will do it in the most efficient manner. So first of all, I introduced with to spanning a graph, and I told you that to span the whole graph you need to visit all the vertices. So let me give you an example. Say your cable internet provider needs to connect homes in multiple streets to provide services. Let's say they need to connect multiple neighborhoods. Now, in such a case, they need to span the whole area. Now, if a company is getting run by intelligent people, they know that they need to do it in the most cost effective manner. So they need to save the money there. And hence, we should do spanning in the most effective manner, most efficient manner. And what does it mean to span the graph in the most efficient manner? It means that why not span it with the minimum number of edges? If you're spanning a graph, let's span it with a minimum number of edges so that you visit each and every vertex, but you don't overrun onto any extra edge. You just run over minimum number of edges. So a spanning tree. Now, a spanning tree is basically just spanning a graph. So that means that a spanning tree is a tree. First of all, it's a tree that connects all the vertices of a graph with the minimum possible number of edges. We have minimum possible edges in this. Now, let me tell you a fact. A tree which has n nodes has n minus 1 edges. Always. Now, why is that a case? It's obvious. Because there is no cycle and every vertex has at least one edge connected to it. Now, so every edge contributes to one extra edge except the first one. Hence, a tree which has n nodes has n minus 1 edges. A spanning tree has the name tree in it, and hence it's a tree itself. Hence, it contains n minus 1 edges always. So, I introduced you with the concept of spanning tree, but I didn't tell you how we'll perform this task of spanning a graph with the minimum number of edges. So that was the point of this video. I just wanted to introduce you with the the concept of spanning tree, with the concept of trees, and then with the concept of spanning tree. And I introduced this to you because I'm going to cover some algorithms which are related to this in the next video, and basically we are going to cover minimum cost spanning tree. So this was a short video. This is it. So let's meet in the next video and look at this topic and the applications of this particular thing. Until then, peace out.